So we will go for the FRIIS transmission equation. So it gives the FRIIS transmission equation. It gives that if two antennas are there, they are separated by a distance r. What should be the transmitting power, gain, and aperture of the antenna? These are the three prominent parameters. Another parameter also consider. So to receive the receiving antenna. So PT is the transmitted power, this is the gain, and power EIRP. Then what will be the loss? Then what will be the receiving antenna gain and receiving power? So transmitted power, how much power you will transmit, how much power you will receive based on these parameters. That is, what will be the transmitted power, gain of transmitting antenna, what are the losses, and what are the gain of the receiving antenna, and what minimum power you require at the receiving antenna. This way you can estimate. So consider two antenna oriented towards the maximal gain of, they are directed toward each other and separated by a distance d, a distance r. So for here, as I mentioned, PT, GT, AT, PT is the power of the transmitting antenna, GT is the gain of the transmitting antenna, AT is the effective area. Just now we have considered what is effective area. Effective area of the transmitting antenna. And same parameter for the receiving antenna. That is, PR is the power received, GR is the gain of the receiving antenna, PR is the effective area of the receiving antenna. In the direction of the receiving antenna, the transmitting antenna has the power EI RP equals to PT GT, power of transmission, and GT is considered and established a power density at the distance R. So this PT can be given by PEIRP divided by 4 pi r square. 4 pi r square, from where it comes? This is what the 4 pi standard sphere we are considering, and r square. So it is PTGT upon 4 pi r square. What this is transmitted PT, that is the total power transmitted. Okay. Then from the incident power, that is PT, we can receive antenna, and the external power PR given in terms of the effective area here as follows. So the received PR, power received at the receiving end, the power at PR received by the receiving antenna is called ARPT. AR is effective area of the receiving antenna, and PT, just now we have PT is this is what PTGT AR upon 4 pi r square. So this is called the FRIIS formula. Whatever the power received by the receiving antenna is depend on power transmitted by the transmitting antenna, gain of transmitting antenna, aperture of the receiving antenna upon 4 pi r square. So what we can say here simply, the power at receiving antenna is directly proportional to the power of transmitting antenna. Means when we will increase the power of transmitting antenna, receiving antenna power will increase. When we will increase the gain of transmitting antenna, the receiving power will increase. When we will increase the aperture, effective aperture of a receiving antenna, then power will increase. And 4 pi r square. R square means as we will increase the distance, power will reduce with reference to r square. Means exponentially it will reduce. For the shorter distance, you will receive the larger power, because suppose the distance is 1. So you will receive power divided by 1. And for 2 meter, if it is there, so 2 square 4. So it is directly reduced by 4 times. If you have 9 meter, 3 meter, 3 square is 9. So 9 times you will receive as compared to the 1. The other parameter we kept constant. At 1 meter, you will receive suppose x power. So as 2 meter, you will receive 4 times lesser than this. At 3 meter, 9 times lesser than this. So it is exponentially reduced. That is 1, 4, 9, this way. Okay. So this is called the FRIIS formula. It can be modified in so many other, but this is the basic formula. You can put the things. Now, GT, gain of the transmitting antenna, can be calculated. That is 4 pi AT. The AT is the transmitting antenna aperture upon lambda square. But you just put this formula, so you can rearrange this. That is power at the receiving antenna. Our goal remains same. That how much power we can receive. That is PT, GT, GR, lambda square upon 4 pi square. So power PT, GT remains same. AR, you can have GR. Gain of the receiving antenna comes again when you will increase the gain of receiving antenna. There also you can have the larger reception power. Okay, so this is the phase transmission. Again, it can be rearranged PT, AT, AR in terms of aperture area upon lambda square upon R square. So this aperture area, if you will increase of both the antenna, transmitting and receiving antenna, power at the reception increase. Transmitting power you will increase, reception it will increase. So this way it is there. So always inversely proportional to the R square. R square is the distance. So this is what the FRIIS formula. It can be rearranged in the different time, and it can be calculated in terms of dB. Generally, the power is relative power, and it is taken in terms of dB. So this formula, received power in terms of dB, you can have this 2-3 equation. This LF is equal to 4 pi. The free space loss when you are transmitting in the free space, what will be the loss? That is 4 pi R square by lambda. And sometimes it also called the free space gain. So free space gain is the inverse of the free space loss. The parameter remains same. If you will say the gain, so it is the inverse of loss. Okay, so it is lambda square by 4 pi R square whole square. So your power received, that is PTGT into lambda square upon 4 pi R square. So whatever the loss, you can put in GR. So this way you can rearrange. Again, it is PTGT GF, that is the loss or the gain of the free space into GR. So this way the equation comes. And in terms of dB, if you want to rearrange, so PT in dB, GT in dB, and the gain. So instead of gain, we put a loss. Whatever the loss, it should be subtracted. If it is gain, so you can add. If it is loss, then you can subtract. Then GR in dB. Okay. So this gain, the whatever this free space gain, it becomes negative in dB. Okay. Or loss, it is subtracted. So this way you can calculate what will be the power received if you will transfer. So this is the basic parameter of FRIIS. So it is give you the understanding that how the power will received at the receiving end. So these are the some parameters. Now the other input impedance and the other parameter, we will discuss it next.